All right, so we are actually going to skip over 4.2 for a day. I just felt like it was better to do 4.3 before we went back to 4.2. This will be stuff you're more familiar with, and then we'll sort of get back to that circle thing when we circle back to 4.2. Uh, but as you can see today, we are going to continue with trig function, or continue with our trig stuff. And I need to write on this. Okay, so today we're going to look at right triangle trigonometry, which this is something y'all should be familiar with. The SOHCAHTOA stuff, opposite, adjacent, hypotenuse, and all that kind of stuff. So this should be stuff that you're fairly familiar with. Maybe we'll add a little something to it. We're going to evaluate trig functions of acute angles and use a calculator to evaluate trig functions. Use some fundamental trig identities and use trig functions to model and solve real life problems. This is probably stuff you had done in Integrated 3. I'm quite certain. Of course, last year with us disappearing for the last, y'all may not have got into this much. So we're going to start with the 6 trigonometric functions, trig for short, 6 trig functions, and where they come from. So, okay, we're familiar with a right triangle, okay, where we have the right angle there in the lower right. And obviously, if we're looking at triangles, anytime you have a right triangle, you have 2 acute angles along with it. You can't have a right triangle that has an obtuse angle, right? Because if you have a 90-degree angle and you add something bigger than 90, then now it's greater than 180, and angles add up to 180. You wouldn't be able to match the 3 corners together. All right, so notice they're using the little theta symbol to represent the angle that we sort of introduced in section 1. So in reference to angle theta there, we have 3 sides of that triangle. We have a hypotenuse, which the hypotenuse is always the side opposite the 90-degree angle. And then you have the side opposite theta, and you have the side adjacent to theta. Okay? And if you're familiar with the SOHCAHTOA, this is where all our stuff comes from. Opposite, adjacent, hypotenuse. Okay? Using the lengths of these 3 sides, you can form 6 ratios that define the 6 trigonometric functions of acute angle. Now, you've probably, let's see, where is a draw? All right, these are the 3 that we're more familiar with, probably sine, cosine, tangent. A lot of times they're abbreviated SIN, COS, and TAN. Okay, but we also have these 3 other ones: cosecant, which is abbreviated CSC, secant, SEC, and cotangent, which is COT. Okay, now sine and cosecant are basically inverses of each other. They're attached. Cosine is attached to secant, and tangent, it's obvious to see, is attached to cotangent. So if you know the sine, you basically will know the cosecant because they're inverses of each other. Now, right now, what we're looking at is the definitions of these only work when the theta, or the degree measurement, is between 0 and 90 degrees because of that right triangle, right? We said we had 2 acute angles. Acute angles are angles that are between 0 and 90 degrees. All right, when we get back to 4.2 and then move more on what we call this unit circle, we'll start looking at how we can get the sine of angles bigger than that. And the other thing that we are dealing with right now is the sine. All of these are positive. Let me clear this off. Clear all drawings. I think I can draw. All right. Oh, there's Randy. Let me change my attendance real quick. Oh, nice. Somebody needs to mute. All right. So the other, like I said, positive. Everything we deal with today, the sine, the cosine, tangent, on that, we're all going to get positive results. That's just for right now as we're dealing with these. So our SOHCAHTOA, right? That you should have heard before, comes from this right here. SOHCAHTOA. This is what we used to remember from that triangle, how to find our ratios for sine, cosine, and tangent. Sine is opposite over hypotenuse. Right here is our SO. Cosine is the adjacent side over the hypotenuse. And the tangent is the opposite over adjacent. Now, a minute ago, I told you that sine and cosecant, cosine and secant, tangent and cotangent are all associated because they are inverses of each other. So notice sine is the opposite over hypotenuse. So the cosecant, the one attached to sine, is just the inverse. It's the hypotenuse over opposite. Cosine, secant is just hypotenuse over adjacent. And then the cotangent is now the adjacent over the opposite. So as long as you can remember that sine is connected to cosine, you still just need to know this SOHCAHTOA, because you know sine, then you know cosecant, I just got to flip it around. If I know the cosine, I know for the secant, I just need to flip it around. Tangent, cotangent, flip it around. Okay? We good? All right. So if we are given a triangle where we're given two sides, in this case, we're given the two legs, the 3, the 4. We're focused on this angle right here. This is our theta. All right. We have enough information to find the values of these 6 trig functions. All right. We want to find sine. We want to find sine of theta, cosine of theta, tangent of theta, and then the cosecant of theta, the secant of theta, and the cotangent of theta. All right, and we're going to use our SOHCAHTOA, right? Now, this case, we don't know what the hypotenuse is, but given that we've got a right triangle and we're given 3 and 4, what's the theorem we can use to find the hypotenuse there? Anybody know? I'm sure you do. Nobody wants to speak. Right, Pythagorean's theorem, a squared plus b squared equals c squared. If we have a triangle, you square the two legs, that equals to the square of the hypotenuse when you add them together. So basically I have 3 squared plus 4 squared is going to equal that hypotenuse squared. So that's 9 plus 16 equals h squared. That's 25 equals h squared. And therefore h equals 5. So we have a hypotenuse of 5. This is a 3, 4, 5 right triangle. Okay, so now that I have those, right, we can go find the sine, cosine, and tangent. The sine is the opposite over the hypotenuse, which is 4/5. The cosine of this angle would be the adjacent over the hypotenuse, 3/5. And the tangent is the opposite over the adjacent, 4/3. So now since I know sine, cosine, and tangent, all I've got to do is do the inverses to find the cosecant, secant, and cotangent. So the cosecant is the inverse of the sine, so that's 5/4. The secant is the inverse of cosine, so this is going to be 5/3. And the cotangent is the inverse of the tangent, 3/4. All right. Anyone with a problem there? I think we're all fairly good with that. That's why I wanted to go into this section first. All right, now they're just stepping through Pythagorean theorem, and there's the 6 trig functions. All right, now there are certain special angles that you need to, it is very helpful if we know the sine, cosine, and tangent of these special angles, okay? And those are these right here, the 30, the 45, and the 60. Once we go back to that unit circle, 30, 45, 60 degree angles, then we're going to add in zeros and 90s too. And they may add that in here. But it's very helpful to memorize what these are. And you'll notice, and here also we're mixing in the radian measure. 30 degrees is the same as pi over 6, 45 is pi over 4, 60 is pi over 3. Okay, but the sine of 30 degrees is 1/2. The cosine of 30 degrees is square root of 3 over 2. The tangent of 30 degrees is square root of 3 over 3. Sine of 45 degrees is square root of 2 over 2. Cosine of 45 is square root of 2 over 2. The tangent is 1. Sine of 60. Notice how the sine of 60 is equal to the same thing as the cosine of 30. It is square root of 3 over 2. It's 1/2, and then the tangent is the square root of 3. All right. So it kind of looks confusing to start with, but really for the sine, 1/2 square root of 2 and the square root of 3 over 2, all right, are the 3 numbers there. And really what is, this is really square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. It's just the square root of 1 simplifies. So the denominator for all these cosines and sines is 2. And the 30, it goes 1, 2, 3 on the top, the square root of 1, the square root of 2, square root of 3 for sine. For cosine, it works backwards. Square root of 3, square root of 2, square root of 1. And then the tangent is a little bit different in that it has square root of 3 over 3, 1, and then square root of 3. So we'll look at these and let's see what it says. Note that sine of 30 equals 1/2 equals cosine of 60. This occurs because 30 and 60 are complementary angles. And in general, it can be shown from the right triangle definitions that cofunctions of complementary angles are equal. All right, but let's move on. All right, so based on that right there, and this is something I don't necessarily know we need to memorize. We can have access to this chart, but they're talking about they being complementary. If you notice, that's what they said. Because the sine of 30 equals the cosine of 60. They're complementary angles. Complementary angles are 2 angles that add together to 90. So that's where they're getting this right here. Sine of 90 degrees minus theta equals cosine of theta. 90 minus 0 is how you would find the measurement of something that's complementary. And this is this chart if you will pull up on WebAssign, let me see. Let me get student view. It should be under my ebooks. Yeah. You just need to go to section 4 or 2 in the book. 4.3, I'm sorry, 4.3. And this chart's there. Tangent 90 degrees minus theta is equal to cotangent. Secant is equal to, I don't need to go through those, but those are the things, are some relationships that we will be dealing with. And there it is. On page 275 of the book. All right, I'm not going to go through that right now. We're not going to do the degrees, minutes, and seconds right now. So let's go on to what they have here, trig identities. All right, so here is sort of the same thing we were doing. We were comparing sine, cosecant, cosine, secant, tangent, cotangent. These are the ones we were just talking about a minute ago. Sine, cosecant is the inverse of sine. So we could say that the sine of theta is equal to 1 over the cosecant, and then the cosecant of theta is equal to 1 over the sine. Okay, that's just another way of saying the inverse. Whenever you put something under 1, that's making it its inverse. You're basically flipping it. All right. Here are a couple other identities that we'll get to, that the tangent of theta is equal to the sine over the cosine, which makes sense because we said in SOHCAHTOA, the sine was the opposite over the hypotenuse, cosine was adjacent over hypotenuse, and the tangent is opposite over adjacent. Opposite comes from sine, adjacent comes from cosine. Notice sine over cosine is tangent. That means cotangent is equal to cosine over the sine. And then some Pythagorean identities that come from this are those right there that we may get to and do some things with as we move along. And this, once again, this chart is in your book, and you can find that on WebAssign too. So you may want to print off a couple of these pages at home. All right, so let me see what they're doing here. Let theta be an acute angle such that cosine of theta equals 0.8. Find the values of sine and tangent using trig identities. All right, so let's follow this along. They're giving us that the cosine of theta equals 0.8. And they want us to find out what is the sine equal to. All right. And the tangent. So what we've got to do is we've got to use these identities, all right, to help us be able to calculate or see if there's going to be something that compares sine and cosine, so that we can see so if we can gather what sine is from the cosine. All right. If we go back to these identities, notice none of these identities compare sine and cosine except this one right here. This is the only one that compares sine and cosine. So that's why they chose sine plus, because what we've given is we're told that the sine squared of theta plus, we know the cosine of theta is 0.8. So what we have is 0.8 squared equals 1. So now what we can do is solve this for sine, right? We can square 0.8, which 0.8 squared should be what? 0.64? Let me get it, make sure I've got my decimals right. 0.8 times 0.8 is 0.64. So what we have is sine, and what we're going to do is treat like this just like it were an x. So we've got the sine square root of theta plus 0.64 equals 1. So I'm going to subtract 0.64, and I'll get the sine square root of theta equals, what's 1 minus 0.64? 0.36. And then to get sine, I've got sine squared, we've got to take the square root of both sides. And that's going to give me what sine of theta is, which the square root of 0.36 should be 0.6, right? I don't have a regular calculator over here. Square root, where's my square root button? Square root is 0.6. So the sine of theta equals 0.6. So because we knew the cosine of theta was equal to 0.8, we were wanting to convert it to sine or find out what is sine. I went to my little identities, found the two that had sine and cosine in it. All right, now it wants us to find what's tangent from there. Well, if I go back to those identities, tangent is 1 over cotangent. That doesn't help me. Tangent is sine over cosine. Notice that's going to help me there because now I know the sine and the cosine. So is sine over cosine. Where are we at? Is sine over cosine. Well, I know the sine is 0.6 and I know the cosine is 0.8. And so what's that going to reduce to? 0.6 over 0.8 equals 0.75. So I know the tangent of theta is equal to 0.75. All right. So you can study over these and memorize them. But like I said, I'm going to let you have access to them. I'm not asking you to memorize them. Let's see. There's that. And there's where they get that. Applications. All right, many applications of trigonometry involve a process called solving right triangles. In this type of application, you're usually given one side of a right triangle and one of the acute angles and are asked to find one of the other sides. Or you are given two sides and asked to find one of the acute angles. All right. Angle of elevation, notice, is an angle that's going up. Another application may be given an angle of depression. That's if you're looking straight out in the angle of going down to the object. So if you're in an airplane and you want to know what your angle of depression down to the ground, if you're on the ground, you would know what your angle of elevation up to the airplane. So make sure we got those. All right, so the rest of this is just going to be using these trig identities to solve for missing links. All right, it says a surveyor standing 50 feet from the base of a large tree. Let me widen this out. As shown in this figure, the surveyor measures the angle of elevation to the top of the tree. I don't need that. Whoa, what's going on? All right. How tall is the tree? So what we've got here is we're 50 feet from the tree. Here's the top of the tree. And then we know this angle of elevation right here is 71.5. And they're wanting to know how tall is that tree, right? So now this is back to our general SOHCAHTOA stuff. Okay. We are given the adjacent side and we are looking for the opposite side and we're given the angle. What's the trig function that compares opposite and adjacent? That's tangent. So we know the tangent of 71.5 degrees is going to be equal to the opposite of x. That's what we're looking for over the adjacent of 50. So now we just have this equation. Tangent of 71.5 equals x divided by 50. and we need to solve for x. Well, how would we get x by itself? We would multiply both sides by 50. So we know 50 tangent of 71.5 equals x. All right. And then if we want to get, that's obviously, if somebody told you, well, how tall is that tree? And you said, oh, it's 50 tangent of 71.5. Nobody know what you're talking about, right? So you do need to, from there, go to your calculator. Now, make sure when you have a calculator, calculators they can measure degrees in degrees or radians. And obviously, this is a degree right now. We'll start using radians more often, but right now, this is a degree, so you need to hit your mode on your calculator and make sure it is in degree mode, which this one is. And then all I've got to do is type in 50 tangent of 71.5, and it's about 149. X is about 149 feet tall. Okay, and that's something y'all probably have done in the past. All right, let's see if they give us another example, if that's it. I think that's the end of my thing. Let's see. Let's do one where we're finding the angle. So let's say we've got this triangle here, where here's theta that I'm looking for. This is 400 yards. Here's my right angle. This is 200 yards. All right, how can I find my theta there? Well, here's theta. I'm given what? Opposite and hypotenuse. Now, which one of these? SOHCAHTOA compares opposite and hypotenuse. Sine. So we know the sine of theta, that angle, is going to be the opposite, which is 200 over 400, right? Which is 1/2. The sine of theta equals 1/2. Now, that was one of those special triangles we did earlier, which I think sine counted up 30, 45, 60 to square root of 1, square root of 2, square root of 3. So I believe this is going to be 30 degrees. But on your calculator, what you can do is if you type in 1/2, I'm sorry, you got to do the inverse on your calculator. Above sine, cosine, and tangent is those little sine -1, cosine -1, tangent -1. So if I hit second sine -1 of 1/2, I hit entered, I do get 30. So theta equals 30 degrees. So if you want to find the measurement of the angle, basically what we have to do is what's actually happening is if I take the inverse sine of both sides, the inverse of sine leaves me theta, and then that will give me the measurement there. So I believe that is all that we're really covering on this. Yep. So I think a lot of it is just going to be sine. And then after this, we'll drop back into the unit circle and things like that. So I'm going to stop sharing first, and then I need to stop the recording somehow. Let's see.
You said you were going to give us like the when it's like 30, 60, 30 degrees, like 60 degrees. Because it was like 1/2.
Yeah, I can write it on the board.
Okay.
It's also in the book off WebAssign. if you go to the ebook, it's there too, but I'll put it on the board so for when you're in class here, if I can figure out how to get out of this.